Hi folks, this is the second of 3 parts to the session covering central place theory. In this part we will develop the hexagonal geometry of trade areas surrounding urban places. In the third part of the session we will stack those layers to create complex urban landscapes. We're going to end up in this theory, central place theory, with a geometric trade area, and the form of geometry is a hexagon. So if you're not familiar with hexagons, they are 6-sided geometries, and for the most part the 6 sides are of equal length, and the angles created by the intersection of these sides is of a similar magnitude, so this is a very regular geometric shape. Now, the reason that hexagons we'll look at in a succession of slides, but basically the hexagon provides the closest packing of points which exist at the center of the hexagon. So you can get those points as close as possible using an array of hexagons without there being any spaces that are not covered by the hexagons. Now, I'll show you why that's important in just a minute. First, some definitions before we get to the pictures about hexagons. A threshold. A threshold in general is not a spatial concept. We are going to make it spatial in just a minute, but the threshold itself is the number of people, and really what we're talking about is the purchasing power, the demand for a commodity. But we're going to think about it, we're going to count it in terms of numbers of people that are required to just keep a business open, the breaking even point. So this allows for the purchase of supplies for the business, the rent of the store, the salary for the people who work for you, a salary for the proprietors as well. And the basic underlying truth here is that if you are offering higher order goods and services, you need more people in your trade area in order to reach that breaking even point. That if you're selling bread, everybody's going to buy bread, right? If you're selling Mercedes-Benz cars, only a few people are going to purchase Mercedes-Benz automobiles. Therefore, you need a much larger population in your trade area to keep the business open if you're trying to sell higher order goods and services. All right, now let's spatialize that. The inner range is this direct spatial corollary of the threshold, i.e. it is the area, the minimum area, that will generate the threshold population or the threshold spending power. So if the trade area is too small, by implication, the business will not survive. The outer range is the farthest distance that people are willing to travel to consume a good or service. Right? So at some point, you are no longer willing to travel to consume a good or service because the cost of that travel is too expensive relative to the value of the good or service that you are seeking. Now, if we look at the comparison of the ideal versus the inner range, we can see what happens. If the ideal outer range, which is the minimum area that will sustain a business, is greater than the maximum possible distance that people will travel for that good, then you won't stay in business because people are not going to be willing to travel to consume that good or service. If the real outer range, the maximum distance in context of other opportunities to consume, in other words, the real outer range can be constrained by competition. If the ideal outer range is the maximum possible distance that you would go, the real outer range is the maximum possible distance that you will travel to consume a good or service, given that there may be competitors on the landscape. So we'll have to see how that plays out. Okay, so here's the basic geometry of what we're looking at. So to show you, we've got a figure that looks something like in figure 8. You've got 2 sets of concentric circles arrayed one on top of the other. At the center of both of these circles is a a place, an urban place where retailers are offering their goods and services. The inner range in this diagram, the threshold, which is the minimum area needed to stay in business, is labeled with the number 1. It is the inside of the darkly shaded circles. And what you can see is that the inner range for both places is sufficiently large that the business should be profitable, should stay in place. The ideal outer range, the distance across which consumers are willing to travel, is denoted in the diagram with number 3 and the dashed line around the figure. In other words, people are willing to travel much farther than is necessary to keep the business going. This, without competition, would generate excess profit, more profit than the breaking even point. But in fact, the landscape is a competitive one where there are multiple players in the retail sector and in the service provision sector. So in this drawing, there are 2 urban places that are both offering the same kinds of goods and services, the upper and the lower. What happens is that the real outer range, which is how far people actually travel, will be constrained by that competition. So what you see is that if you can imagine the dark shaded circle, they're overlapping, aren't they? And so the real outer range, when there is no competition, is labeled as number 2, and it's the longer of the number 2 lines with the arrow on it. But when there is competition, then people are not willing to travel that full distance because there might be some place closer that they could go to buy the same thing. So what happens is that you bisect the overlapping region. So instead of a circle, you have a straight line. So I'm going to highlight that straight line for you with my little nifty red pen here. What that shows you is that the overlap between these areas becomes bisected with a straight line, and that is going to eventually result in the hexagon when you populate the landscape with all kinds of competitors. All right, let's see this play out a little bit more. So here's a progression of diagrams. There are 3 rectangles arrayed one on top of the other on the right-hand side of the slide. At the top, each dot represents an individual dispersed farmstead. This is a circumstance where you've got a featureless plain. There's no underlying differentials in soil fertility or in climate, so any place is as good as any other. So the farmers array themselves doing their own thing in their isolated little farmsteads. There is a hamlet that develops on the landscape where farmers go in to buy supplies and to sell their goods and to go see the doctor or whatever. That hamlet is the larger circle at the middle of the top diagram. The yellow shows you the inner range, the threshold purchasing power that is needed to sustain that hamlet and the kinds of goods and services that are offered there. The orange ring around the yellow, it's encased in the solid line, the solid circle, is the ideal outer range of the good, meaning that the farmers who live outside of that circle are not willing to travel to that hamlet to consume those goods or services. Okay. Now, the second diagram, the stage 2 in this process in the middle, what it shows you is that eventually there will come to be hamlets arrayed across the landscape, because they are going to come in and they're going to take advantage of the demand for goods and services and try to make profit. Now, you can think of this arrangement like billiard balls. If anybody's played billiards, when you put them together in the triangle, I forget what the name of that is. It can show you how much I play billiards. You pack them as closely as possible, and it looks very much like that middle diagram, where the ideal outer range, this farthest maximum distance that consumers are willing to travel, bumps up against one another. The problem, however, is that there are these interstitial areas, the green areas in between the billiard balls, this dead air, that represents unmet demand. And in a capitalist economic system, unmet demand cannot survive. It must be addressed. There will be changes to the underlying system in order to try to reap benefit from that unmet demand. So in a sense, what you do is you take these circular ideal trade areas, or these trade areas defined by the ideal outer range, and you squish them together, and you end up with the figure at the bottom. So that every pair of hamlets will have, bisecting the distance between them, a boundary of the trade area. So what you see is that the geometric properties of hexagons will produce this arrangement of urban places across the landscape that maintains the largest possible size of the trade area for the retailer, and it will provide the minimum amount of travel for the consumer. So it's a win for both sides, both groups of economic agents. This ends the second of the 3 parts to the session on central place theory. The third and last part will stack the layers of hexagonal trade areas surrounding urban places to create complex urban systems.